Number 6, find an expression for u. Now this is the sum equation. So the sum equation for geometric, right? First n terms of a geometric are given by. And so what we know for a sum is going to be a of n plus 1. Oh, let's see. I want to do it this way. I want to do a of n, right? Yeah, a of n is going to be the sum of the second one minus the first one. And I think what they did brilliantly is they did n minus s of n minus 1. It's just so much easier the way that they did it. Because if you had, let's say you had 2, 5, 8, 11, that's not geometric, but when you're adding these up, if you had a sum which was 7 and 15, if you want to know what this one is here, you would just go this sum, or if you want to know what the value in between, you're going to take this one minus this one. So this should give us our a of n. So we're going to go 7 to the n minus a to the n over 7 to the n. And then we're going to subtract 7 to the n minus 1. I'm going to get rid of my little graphic here. 7 to the n minus 1 minus a to the n minus 1 over 7 to the n minus 1. That should give us the equation for what the function is alone. Now the first term is easy now because let's let n equal to 1. And what is it? Well, a of 1 is going to be 7 minus a over 7 minus, what's 1 minus 1? 1 minus 1 is 0, so 7 to the 0 minus a to the 0 over 7 to the 0. See why I picked that? And you're going to get 7 minus a over 7 minus what's 1 minus 1? 0 over 7. So this is just going to be 7 over 7 minus a over 7, which is 1 minus a over 7. That's the first term. You ready for the ratio? Next. For the ratio, we're going to look at the second term and see what the ratio is between them. So this is going to be for the second term, you're going to put a 2 in here. 7 squared minus a squared. Yeah.
Is Andy Smith in class?
Who?
Ann Smith?
Yes.
Am I in the wrong room?
No, yes, she's here.
Oh. Please have her go see your guidance counselor
Can she do that at the end of the hour?
at the end of the hour. Thank you.
Perfect. Thank you. Minus 7 to the first minus 8. I thought she said Andy. It sounded like Andy. So you subtract those. So now what you have here is 7 squared, or 7 squared minus a squared over 7 squared, and then this is going to be 7 minus a over 7. So when I simplify that, I'm going to think of this as 7 minus a, right, over 7 times 7 plus a over 7. Does that work? Minus 7 minus a over 7. What can I factor out of those two? 7 minus a over 7. What's left here? 7 plus a over 7 minus 1. So that's going to be 7 minus a over 7. 7 over 7 is 1 minus 1. This is a over 7. What's cool about that? What's awesome about that? What's incredible about that? What was my first term? 1 minus a over 7. What do you see here? 1 minus a over 7 times a over 7. So what's this thing here? There's the ratio. That is a little tough, but I can get it. It makes sense when you use this to find the first term and the second term. Now we have the ratio. Now we have the first term. Now we're ready to do this part C. Determine the values of a where the sum to infinity exists. So we talked about this already. A over 1 minus r works when r is between what? 1 and negative 1. Of course, they said in this one, a is greater than 0. So we're looking at r between 0 and 1. Because the negative 1, the a can't be negative. Or r can't be negative. Actually, yeah. So in place of r, I'm going to put my ratio, which was a over 7. So multiply everything by 7, I get 0 times 7. And I get 1 times 7. What's a going to be between? 0 and 7. Very good. And then it says, find the sum to infinity when it exists. This is classic HL, just classic. A over 1 minus r. A was 1 minus a over 7. Over 1 minus r, what's r? A over 7. So what's 1 minus a over 7 over 1 minus a over 7? 1. That's the sum to infinity.